Good morning. Myself Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is static latches and registers from the unit 3, that is sequential logic circuits, in the subject of VLSI design. Let me discuss. Yeah. First of all, static latches and registers are fundamental components in digital circuits, specifically in a sequential logic design, where they store data based on the control signals. Then, uh, detailed explain here now. Let me see the detailed explanation of static latches. A latch is level sensitive. A latch is a level sensitive storage element that hold your values as long as it is enabled. Static latches store data using feedback loops between transistors, and they are called static because the stored data is held indefinitely without the need for refresh as long as power is supplied. Uh, Types of static latches. Mm, there are four types, that is flip-flops. SR flip-flop, JK flip-flop, toggle T flip-flop, and D flip-flop is also a SR latch, that is a set research structure built from NOR and NAND gate with feedback. It has two input, that is S and R, and two output, Q and Q bar. Yeah, already we know the operation. What when S equal to 1, R equal to 0, latch is set. When S equal to 0, R equal to 1, the latch is reset. When both are 0, the latch is hold state. When both are 1, it leads to one invalid condition. And D latch. Also, its operation already we know. However, I will explain the operation of the D latch. When yeah, that is enable equal to 1, the latch is transparent and the output follows the input. That is Q equal to D. When E equal to enable equal to 0, the latch hold the last state. And level sensitive latches are sensitive to the level of the clock and enable signal, meaning they store data as long as control signal. Also, let me talk about the static register. A register is a sequential element that is composed of multiple flip-flops which store data synchronously based on the clock signal. A register stores multiple bit of data and is used to store indeterminate result data for processing or value for transfer between modules. Types of register: D flip-flop based register, JK flip-flop based register, shift register. And unlike latches, registers are sensitive only to the clock edge, when makes them more stable for synchronous system, that is edge triggered. Register are edge triggered device. And let me see some of the difference between latches and registers. When we are considering the triggering, latches are level triggering and registers are edge triggering. For storage, latches hold data as long as the enable signal is active. If the register hold data until the next clock edge, and it latches are very simple using few transistors, while comparing the registers more complex and uses flip-flops, and data can change as long as the enable is active for latch. For register, data changes only on the clock edge. Well, and um, yeah, positive feedback. Yeah. Here you can see the negative latch and positive latch. Negative latch transparent when clock is 0, and positive latch transparent when clock is 1. And then after sleep. Yeah, insensitive to clock overlap. Here you can see positive latch, negative latch. Ways to design an edge-triggered sequential cell, that is massive slave latches and pulse-triggered latch. Okay. Static latches are level-sensitive storage devices that hold data based on the enable signal, while static registers are edge-triggered and store data on the clock edge. Latches are simpler and are often used in asynchronous system or in circuit where level-sensitive behavior is needed. Registers are more complex and used for clocked synchronous systems such as processor and memory units, where stable data retention and timing are crucial. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.